This is the practice assessment for the quiz on sections 5.5 to 5.8. So in problem number 1, where it says solve the cosine of x is equal to negative square root of 3 over 2, it specifies a domain, which is from 0 to 360 degrees. That means a full circle. The reason that's really important is because in All Students Take Calculus, there are 2 quadrants where the cosine will be positive and 2 quadrants where they'll be negative. Now, since we're finding a cosine of an angle being negative, which is important, we got to figure out what quadrants cosines are negative. Well, everything's positive in quadrant 1. The other quadrant where cosines are positive is quadrant 4. So we must be looking for an answer in quadrant 2 and 3. Now, you solve this by doing in your calculator the inverse cosine of negative square root of 3 over 2, which is going to give you 150 degrees. And that's your answer in quadrant 2. But the calculator doesn't give you the answer in quadrant 3. You're going to have to find it. So you need to know what the reference angle is. 150 has a reference angle of 30 degrees. So the quadrant 3 angle, whose reference angle is also 30 degrees, is going to be at 180 plus 30, which is 210. And those are the 2 angles that if you take the cosine of them, you'll get negative square root of 3 over 2. Number 2, I'd love to tell you that if you put the sine of arctan, remember arctan is the same as inverse tan, in your calculator that you're going to get a nice answer, and the problem is you're not. So in order to determine the answer, we're going to have to draw a picture, which is why I said, draw a picture. So this is how it works. You start with this. Remember the inverse, or arctan, is the same as saying the tangent of some angle is 5 over 6. We're going to just assume it's in well, I'm not assuming. It tells me it's in quadrant 1. So I'm going to draw a triangle in quadrant 1. There's my quadrant 1 triangle. The tangent's 5 over 6. Tangent is opposite over adjacent. Now if I use the Pythagorean Theorem to find the missing side, which is the hypotenuse, 6 squared plus 5 squared is, I'll call it r squared. So 36 plus 25 is r squared. 61 is r squared, so r is the square root of 61. And now I can find out what the sine of that angle is. Now I'm going to do this part. The sine is going to be 6 over the square root of 61, which simplifies to 6 the square root of 61 over 61. Number 3, solve the triangle if angle B is 42 and side B is 4.5. Remember, solve the triangle means find all the missing sides and all the missing angles. Make a chart. Fill in your givens. And now you can find the missing angle first. So the easiest thing to find is angle A, which is 48 degrees. And then it doesn't matter if you find side A or side C. I'm going to find side A just because I work in alphabetical order. So if I know angle B, and I know side B, which is the side opposite, and I want to find side A, which is the adjacent, I'm going to use tangent. So I'm going to do the tangent of 42 is equal to 4.5 over A. And then I'm going to cross multiply. So I'm going to get A times the tangent of 42 is equal to 4.5. Then I'm going to divide by tangent of 42, and I'm going to get 4.5 over the tangent of 42, which when correctly rounded is going to end up being about 5. And now the best way to find C, you can use another trig function, but I probably wouldn't. I'd use the Pythagorean Theorem. I would do 4.5 squared plus 5 squared is equal to C squared. You're going to get 45.25 is C squared, so C is approximately 6.7. So there was my missing information. I found angle A first since I knew 2 of the 3 angles. And then I found side A, although it didn't matter which one I found. I started with the given angle, which was that B was 42. And since I knew side B, that's the side opposite, and A was the side adjacent, that's how I decided I was going to use tangent. Then once I knew 2 of the 3 sides, I used the Pythagorean Theorem to find the third side because it is a right triangle. We're going to use that triangle one more time, and we're going to solve the triangle if side B is 18 and side C is 52. Okay, so remember when we are solving a triangle, we're going to make a chart, and we're going to put in our givens, and I know angle C, I know side B and side C. Now, I will tell you that you can use the law of sines to do right triangle trig. We usually don't. We usually use regular SOHCAHTOA, but if you want to use the law of sines because you've become very comfortable with it, you will still get the right answer. So you'll notice because it's a right triangle, I know 2 of the 3 sides. I'm going to use the Pythagorean Theorem to find the missing side, which is A. So I'm going to do A squared plus B squared is equal to C squared. So I'm going to do 52 squared. I'm going to subtract 18 squared from it. And then I'm going to square root that answer. And I'm going to get about 48.8. Now I need to find a missing angle. And how about I find A, because it's first. So given the information from the original triangle, notice that I know the adjacent side and the hypotenuse. So the best way to attack that problem is probably to use a cosine. So cosine of A is going to equal adjacent over hypotenuse. So in order to find angle A, we're going to do an inverse cosine. So the inverse cosine of 18 over 52 is about 69.7 degrees. So 69.7 degrees. And once you know 2 of the 3 angles inside the triangle, you can find the third one by subtracting from 180. And I'm going to find out the missing side, or angle, is 20.3 degrees. And again, you could have used the law of sines to solve. You could have done sine of 90 over 52 is equal to the sine of B over 18, and you would have ended up with the same answer. So if you're more comfortable with the law of sines, feel free to use it. It does work on right triangles, but you can't use right triangle trigonometry on non-right triangles. Like problems like number 5. In problem number 5, it says, find the area of triangle DEF if E is 18.6, angle E is 78.2 degrees, and angle F is 41.3 degrees. We had an area formula that said you can find the area, if you know 2 angles, you can find the third one, which is 60.5, by doing 1/2 of the given side squared. So since E is the given side, we're going to put sine of angle E in the denominator, and the other 2 angles will go in the numerator. We'll do sine of 41.3 times the sine of 60.5. And then we'll just plug that into our calculator verbatim. Just don't forget to close the parentheses on your sines when you plug this in your calculator. And we're going to find out that the area is about 101.5 square units. Don't worry, I'll give you this formula on the test. However, the formulas I give you are for triangles ABC. You need to use that. You need to know how to use them if I call the triangle some other set of letters. In problem 6, we want to determine how many possible solutions there are for each of these triangles. So for problem 6a, remember I said that if the original angle I give you is obtuse, then there's only the possibility of 0 or 1 solution. How are we going to know which one it is? Well, set up your little chart. I know this is 145 degrees, BC, and then side A is 14, side B is 8. I don't know side C. In order to figure out if it's 0 or 1 solution, all you have to do is find angle B. How are you going to find angle B? Law of sines. The sine of 145 over 14 is equal to the sine of B over 8. When I cross multiply, I get 14 sine of B is equal to 8 sine of 145. I'm going to divide by 14. And then I'm going to take the inverse sine of, oops, I forgot to put the 14 there, of 8 sine of 145 over 14. And I'm going to get B is 19.1 degrees. Therefore, there must be 1 solution. In part B, since the original angle is acute, I don't know if it's going to be 0, 1, or 2 solutions. So, I'm going to set up my chart here. ABC, little a, little b, little c. There could, however, be a second solution. So I'm going to set up for the possibility that that could happen. Now, the nice thing about no solution is you're going to know in the first step if there's no solution or 1 or 2 solutions. Because in the first step, if you get an error message on the calculator, that means that there's no solution and you're done with the problem. You don't have to do any more work. You can't do any more work. All right, so we're going to go and find angle B. So we're going to do the sine of 60 degrees over 4 is equal to the sine of B over 12. I'm going to cross multiply, and I get 4 times the sine of B is equal to 12 times the sine of 60. I'm going to divide by 4. And I'm going to do the inverse sine of 12 sine of 60 over 4. And you get an error message, which means that B here has no solution. Number 7, solve the triangle if side A is 15, side B is 10, side C is 22. Well, in this case, I've been given 3 sides and no angles. When you're given 3 sides and no angles, in order to solve the triangle, you're going to have to start with the law of cosines. The only time you can use the law of sines is when you know a side and its corresponding angle. But if all you know are sides, you're going to have to use the law of cosines. It doesn't matter which angle well, it does really matter which angle you find first. You want to find the angle associated with the largest side. And since the largest side is 22, we're going to find angle C first. So, the law of cosine says side C squared is going to equal A squared plus B squared minus 2AB cosine of angle C. And we're going to start by subtracting 15 squared and 10 squared. We're going to divide by negative 2 times 15 times 10. And then we're going to take the inverse cosine of that sine. And the way that you should put it in your calculator, I'll actually write it the way you should plug it in your calculator. You should do inverse cosine, and then in parentheses, well, actually, before you do inverse cosine, let's do it this way. You should do parentheses 22 squared minus 15 squared minus 10 squared divided by parentheses negative 2 times 15 times 10. Get that answer, and you'll get negative 0.53. And then I would take the inverse cosine of negative 0.53. And the inverse cosine of that is going to give you 122 degrees approx. That's rounded. Okay, so now I know, I'll use a different color, that this is 122 degrees. Now you can find the law, you can use the law of sines to find the another angle. It doesn't, you can use the law of cosines if you want, but you probably don't want to. So we're going to use the law of sines to find the next biggest angle, which is going to be angle A because side A is 15. So now I'm going to do the sine of 122 over 22 is equal to the sine of A over 15. When I cross multiply, I'm going to get 22 sine of A is equal to 15 sine of 122. I'm going to divide by 22. And then I'm going to inverse cosine, or inverse sine that. And I'm going to find out that angle A is approximately 35.3 degrees. Well, now that I know two of the three angles, in order to find the third angle, I'm just going to subtract the other two from 180. And I'm going to find out that angle B is 22.7. Remember, the best way to check if you probably did this right, the largest angle should correspond with the largest side, and the smallest angle should correspond with the smallest side. And that's the practice assessment for 5.5 to 5.8.